In section 1.1, we look at linear equations and applications. First, let's talk about linear equations. Linear equations are any equation that can be written in this form here, ax plus b equals 0. A and b are real numbers, and a itself cannot be 0. And this is the most basic type of equation. Now, before we go on to do the example, I want to point out the fact that when you have an equation ax plus b equals 0, the defining factor that it's a linear equation is that the exponent of your variable is a 1. So this is a first-degree equation. All right, let's go ahead and take a look at the following example. Solve the following equation for x. 3 times the quantity x plus 2 minus 2 equals 4x. Now, I will assume that you have had some kind of practice with solving equations in the past, so this will be treated as a sort of review. All right, first thing we want to do with our equation is remove parentheses. In general, parentheses obstruct solving equations. So we're going to use the distributive property here. Multiplying this out, we get 3x plus 6 minus 2 equals 4x. Next thing we want to do is combine like terms. Now in this case, that means we can subtract 6 minus 2 is positive 4, giving us 3x plus 4 is equal to 4x. Now from here, you can do one of two things. Since we're solving for x, we want to get all of our x terms on one side of the equation. Many students prefer to get x on the left-hand side, and in this case would be compelled to subtract 4x from both sides. And you could certainly do this, but it's actually a little easier to subtract 3x from both sides, which would get your x variable over to the right-hand side. Let's go ahead and compare and contrast these two methods. So if we subtract 4x from both sides, as I first mentioned, 3x take away 4x is negative 1x plus 4 is equal to 0. And now you can see that we do have it in the format ax plus b equals 0. But to solve here, what we need to do next is subtract 4 from both sides. And when we do this, we get negative x is equal to negative 4. And finally, to solve, we need to divide both sides by negative 1, which gives us x is equal to 4. However, if we had taken the other approach, meaning recognizing that we can simply subtract 3x from both sides, this gives us 4 is equal to x. And you see we're done right there at that point. So it doesn't really matter what side of the equation you get your x variable on. Mostly you just want to choose whatever is going to be easiest, most efficient, and fastest. In our second example, this is another linear equation. Notice that all of the variables x are raised to the first power. What we need to do here to solve for x is we need to eliminate the fractions. So what I'm going to do is multiply both sides of the equation by the least common denominator. The least common denominator is 2 times 5, which is 10. So I'm going to multiply the left-hand side of the equation by 10 and the right-hand side of the equation by 10. Now when you do this, we're going to distribute 10 to each of these. And I'll show my work on this. We have 10 multiplied by the first fraction, which is x plus 5 divided by 2, plus 10 multiplied by the second fraction, which is 2x minus 1 over 5. On the other side, we simply have 5 times 10, which is 50. Now, the whole point of multiplying by the least common denominator is we can now cross-cancel. Thinking of 10 as 10 over 1, we can see that 2 divides into 10 evenly 5 times, and 5 divides into 10 2 times. And then we're going to distribute what we have left So this gives us 5x plus 25 plus 2 times 2x is 4x. And then plus 2 times negative 1 is negative 2 equals 50. Now if we combine like terms here and combine like terms here, we end up getting 9x plus 23 is equal to 50. Next, I can subtract 23 from both sides, and that gives 9x equals 27. And finally, we can divide by 9, which will give us x is equal to 3. The other thing you'll notice when solving linear equations is that you will only get one solution. You'll never get 2 solutions or 3 solutions. So when you have a linear equation, because it's a first-degree equation, you only get one solution. In our next example, we look at solving an equation involving decimals. Now, really, there's no difference in solving this equation, but you do have a couple of options. So the first option for solving this equation is to simply do it as we did the previous examples. So I'll start by distributing here, and you might want to use a calculator. 0.3 times x is 0.3x, plus 0.3 times 2 is 0.6, and then we have minus 0.02x equals 0.5. Now from here, what I can do is combine like terms. We have 0.3x minus 0.02x. So we have to think of 0.3 as 0.30 minus 0.02. And when you do this subtraction, you get 0.28. So we have 0.28x plus 0.6 equals 0.5. Next, we'll subtract 0.6 from both sides. And this gives 0.28x is equal to negative 0.1. And finally, I'll divide by 0.28 on both sides. And this is going to give us x is equal to, now here we have a negative number divided by a positive number. So we know the answer is going to be negative. And you can simply plug the rest into a calculator. And when you do that, you get negative 0.35714 28571. And if you were going to round this answer, this would make a little bit of sense. We could say this is negative 0.36, for example. However, if they want an exact answer, this would not be the way to do the problem. So to get the exact answer, you would have to go back to what we were dividing here, which was negative 0.1 divided by 0.28. And what we can do is we can multiply the top and the bottom by 100. And the reason I do that is because that will move the decimal place 2 places to the right. So that gives us negative 10 divided by 28. And then if we reduce that fraction by dividing by 2, we get negative 5 over 14. So this is the exact answer, and this is the approximate answer. And it's really important when doing homework to pay attention to what they ask for in your answer. In this case, they don't specify whether they want the exact or approximate answer, but in a lot of homework online systems, they will tell you how they want the answer. In the next example, we're going to look at solving for one variable in terms of another variable. So here it says the perimeter of a rectangular fence is 15 feet. Write the width of the fence in terms of the length. So what we really need to know here is that the perimeter of a rectangle is equal to 2 times the width plus 2 times the length. And in this problem, they tell us the perimeter is 15 feet. So we have 15 is equal to 2 times the width plus 2 times the length. Now they want us to write the width in terms of the length. So we want to solve for W, the width. To do this, I can subtract 2L from both sides. Doing that gives us 15 minus 2L is equal to 2W. And then now to solve for W, I simply need to divide by 2. And this is going to give us cancellation here. And W equals 15 minus 2L all divided by 2. And this is an acceptable answer. But you could also rewrite this as 15 over 2 minus 2L over 2. And that would simplify to 15 over 2 minus L after canceling the 2's here. So you can express your answer in either form. There are advantages to each one of these depending on exactly what you would be doing with that formula. But notice when we do this, we don't get an answer for W, right? We don't get a numerical answer for W. W has to be expressed in terms of L because we don't know the value of the length. Now, as another example of applications of linear equations, we can look at simple interest. So simple interest is when you put an amount of money into an account, and the amount of money we call P, which is the principal. We leave it in the account for a specific amount of time, which is normally given in years, and R is the annual interest rate. And then the interest I that you will accumulate in doing this is PRT. So we take the principal, multiply it by the rate, multiply it by the time. So as a simple example, if we had a principal of $400 and we put it into an account at an interest rate of 5%, and we leave it in the account for 3 years, the amount of interest we will have at the end of 3 years will be P times R times T, which would be 400 multiplied by the interest rate R, which we need to change to a decimal, 0.05, and then multiplied by 3. And then from there, we can simply plug it into a calculator to get $60. So at this interest rate for this amount of time for this given principal, this account would earn $60 in interest. All right, now let's look at example 5. In this example, it says John took out a loan at 4% simple interest and repaid it after 5 years. The total amount paid back was $5,760, equal to the principal and the interest. What was the principal? All right. So we know the amount that John paid back was $5,760, and this is equal to the principal P that he borrowed plus the interest that he had to pay off the loan. Well, this is 5,760 is equal to P plus, and then remember, I is P times R times T. We know for this problem, time is 5 years, and we know that the interest rate is 4%, which is 0.04. So if we plug those quantities in, we get 5,760 equals P plus P times 0.04 times 5. And if you do the math on this, we get 5,760 equals P plus, and then 5 times 0.04 is 0.2. So we have 0.2 P. Now keep in mind that this is 1 P here, and then plus 0.2 P. So those are like terms, and if we add those together, 1 plus 0.2 is 1.2 times P. And now we can solve for P by simply dividing both sides by 1.2. And if we do the division there, 5,760 divided by 1.2, we get $4,800. So the principal amount of money that John borrowed was $4,800. Now for our final example, we're going to model tree growth using a linear equation. It says a 20-foot tall white oak tree grows at a rate of 0.8 feet per year. How long will it take for the tree to reach a height of 32 feet? Okay, so let's think about the relationship here. Let's call h the height of the tree, and let's call t time. Time will be in years, and height will be in feet. And right now, we know the height is 20 feet tall. So the height right now is 20. However, it grows every year. So every year that goes by, we're going to add to that height by the amount that it's increasing. It's increasing by 0.8 feet per year. So we have to take 0.8 and multiply it by the number of years that have gone by. So the height of the tree is 20 plus 0.8 times t. Now the question is, when will the height be 32 feet? So what we're going to do is we're going to substitute 32 in for h, and that gives us 20 plus 0.8 times t. Now if I subtract 20 from both sides, we end up getting 12 is equal to 0.8 t. And finally, if we divide both sides by 0.8, we get 15. So it will take 15 years for this oak tree, which is currently 20 feet tall, to reach a height of 32 feet.